Hello people, and thank you for being here. So today we are going to talk about scaling your data infrastructure. I'm going to try to give you some good advices about this. So this is the agenda for today. We're going to talk about the data science workflow. We're going to talk about when scaling is not just a matter of machine, and when the size of your data matters. And we have the last two parts where we are going to talk about containerized data science and how we can put all these things together, and a project I have been working on for the last couple of months called Cassini. There are some chairs here if you want to sit in the front. So let's talk about the data science workflow. I took this picture from Google. Actually, it's from IBM. Hopefully, you can see something. And this is a kind of high-level approach. You can see like a business question here at the top. Then you have some hypotheses or some questions. You start to iterate over this. Then hopefully you build a model and you just try this. So there is this concept of build, iterate, and share, like a kind of endless loop. And I would say it makes like sense. So probably you have a similar kind of solution. Of course, it depends on many things. But we can keep these keywords like build, iterate, and share. So how you build, iterate, and share depends on many things. It depends on your company, on your users, on your product, on your tech stack, on your team, and also on your domain. So it's very specific, actually. But we will try to put two constraints. So the first one is that you use Python, and the second one is that you use Jupyter. So we'll discuss mainly about Python tools. This is a kind of data science toolbelt. So you can see some tools and some libraries that probably you already use or you already know. You can see pandas, you can see Jupyter, you can see scikit-learn. Probably you also know about Docker, and you heard about Ray. And today we're going to focus on this one. Of course, there are like many of them. Like if you are doing like deep learning, you can put like Keras, you can put TensorFlow, you can put PyTorch, and so on. But this will be the main part of this presentation. We'll focus on these libraries. So scaling is not just a matter of machine. You have some other problems that are technical, but not technical in the sense of the size of your machines. You have to worry about documentation. You have to worry about versioning. You have to worry about testing. You want to care about metrics, reproducibility of your models or of your data pipelines, and partially about storage. Now, of course, there are tons of problems about this, and on this part, I will just focus about versioning and about testing, and what you can do with Python and with Jupyter. And the small part will be also about storage. So we all use it, right? I hope you can recognize the Jupyter notebook from this picture. And it's a kind of gate for the data science process, no? You do data science through a Jupyter notebook. You learn that doing data science through a Jupyter notebook. You can write books using a Jupyter notebook. So it's literally like the gate to do your job if you're a data scientist. So, well, it's a very beautiful and amazing tool. It's really hard sometimes to write like an end-to-end solution. So from your lab to production. And so far we didn't have like proper tools, but we started to have something like, I don't know, FloydHub or SageMaker from AWS. So we started to integrate this somehow. But still, for example, there is a huge issue, and it's about versioning. So the way in which you call your Jupyter notebooks, actually. And this is a big issue because you can find like, I don't know, Aki solution to track and to version your Jupyter notebook, but it just doesn't work. The format is not the right one. So if you look like inside the Python notebook at the end is just a JSON file. It's a very rich format. It's very complex. You can put almost everything inside: images, code, tables. And this comes from the IPython notebook documentation. This is not anymore IPython. It's a Jupyter notebook, but they still have the same documentation. And so they started at the beginning with a good idea. So we want to use JSON because it's easy to share. It's going to work. You can version control this. And yeah, you can make your colleagues happy. But basically, it doesn't work. You can't use Git with this. It will be just painful to do code review on a Jupyter notebook. And also, you cannot apply the tools that you already use, for example, for a Python pipeline. So you cannot do like continuous integration or continuous development using, I don't know, Flake, 8, or PyTest, and all these things, because the format is just different. So let's try to look around and to see other examples. So this is RStudio. I think that they got it right. It works quite well. It's a beautiful IDE. And you're just using R format. So you just have a text, and you're working on this. And if you want to publish something, you just use R Markdown, and it's something different, something that maybe you want to do, but you're not going to save the R Markdown file. You're going to save the R file. And you can just work on this, and you can just version this properly. Now, what about Python? So we are not yet there, but we keep improving. This is a Jupyter lab. We have similar user interface. So we start to have like also text file. We start to have like a file browser, and you can also run like code from a text file directly inside a Jupyter kernel, but it's more like a small feature. You need to select the code. It's not like the main use case for now. You still have to use the notebook with the cells. So one thing that we can do is to try to think about a different flow with the Jupyter notebook. I mean, do we really need to have the cells? Or we can just use a text editor, for example. So we can just write Python, save it like a Python file, and we can just execute the code that we want, and we just collect the output in case. Well, we can do this. Hopefully you can see the picture. This is Atom. It's a text editor from GitHub. It's open source, and it's running a Hydrogen plugin. And it's something super cool because you can just run your Python code. You can connect to a local kernel or to a remote kernel, and you can just execute your code. And you can just collect the output on the right side. And what you get from this? So first of all, it's a Python file, so you can version this properly. You don't have to worry. You can run your continuous integration, or you can integrate the file in your pipelines, continuous integration pipelines, and so on. You're not limited by a browser anymore, so you can close the tab, and you don't have to worry about the code or about saving the session. And of course, there are different trade-offs, but for example, you don't have the notebook anymore, so you cannot publish this directly. You need to export this to a notebook if you want. So you will have a similar flow that you have with RStudio, for example. But it's super cool because, I mean, you can attach remote kernels, so you can have your AWS instance running somewhere with the GPU, and you can just connect your local Atom to that machine. So the hard thing about storage. Now, you might think, why storage? I mean, it's really related about the size of your data. Yes and no. Now, the concept of how to store your data, which solution, the platform, the technology, it's very tailor-made on your use case. Probably you can have a conference just for this. So I want to talk about something very specific, and it's about file system storage. And I want to talk about Parquet. So you probably heard about Apache Parquet. It's free and open source, column-oriented file format. It's somehow the cousin of Arrow, and it's like the memory version. And the cool thing about Parquet is that you can store Parquet in S3. It's super easy. And actually, you can query Parquet files using SQL with tools like Impala or Presto or Drill. And I mean, actually, also with Pandas, because you have native support for Parquet. And the cool thing is that you can load also Parquet files directly into your BigQueries. And you can do the same. I mean, you can query Parquet files using Athena, AWS Athena. I think there is going to be a talk about this during these days. So it's super interesting because you don't have to worry about your, well, also your database. You can use this solution. Actually, I'm experimenting with this. It works really well. And if you use object storage, you just don't have to worry about scaling. You just add more files. You don't have limit with the size. Actually, I think you have like 5 terabytes per file, and usually it's not a problem because you can split the files. And it works really well. And also, you don't have the problem about locking because you have different solutions by different providers. You have S3, cloud storage, and you can also implement your own solution. So when the size of your data matters, so sooner or later, you are working with your laptop, but you need more RAM, or while you're training a model, you want to watch Netflix, and you run out of CPU or memory, or maybe it just requires too much time and you need to scale this. So usually you will face these 2 problems. One is it doesn't fit in your RAM, or it's just too slow. Now, of course, there are like many different reasons. You need to dig into this. But let's try to approach scaling from different sides. So the blue hexagons are the ones that you can, the technique that you can use when you have just one machine, for example. The yellow ones are the one that you can use when you have multiple cores or multiple machines. And in the middle, you have a solution that you can use to face both problems. So with Pandas, for example, we have read by chunks. So you can split your data set and you can read your CSV file or Parquet by chunks. You can specify the size of the chunks. And you have something similar with scikit-learn, it's partial fit. So you can learn your models and you can partial fit the same model with new data. And in the middle, you have more complex techniques like framework, like Spark or Dask or Ray. You can also have just a bigger machine, and that's, for me, it's a super cool solution, because actually I think you can get like 1 terabyte of memory currently. Or you can just add more machines. Maybe it's going to be cheaper, but it's going to be painful somehow. So let's talk specifically about read by chunks, partial fit. So they works really well if you just have one machine, of course. But you need to face some non-trivial problems, I would say. So specifically about read by chunks and partial fit, if your results depend on the whole data set, you have a problem because you're reading by chunks, so you're just partial fitting. So if you're doing like feature extraction and you need to worry about the entire data set, just doesn't work. And specifically about partial fit, first of all, it's specific about the algorithm, so it's not something that you can use with all the algorithms inside scikit-learn, but you need to pick the right one. And results can vary, so don't expect the same result. And particularly about classification, you need to worry when you do partial fit that you need to have all the labels that you want to predict, because otherwise there will be just new things and the model doesn't know about them. So it works, it's tricky because you need to think carefully about this, but it's one of the solutions that you can have. And specifically about multiple machine, well, distributed computing is really hard. It's not simple, it's super complex. With Pandas and with scikit-learn, you don't have out-of-box support for this. So they thought about these libraries, okay, I'm going to run this only on this machine. And I think that for them, it goes quite well. I also don't think that it's like a huge problem because, as I said before, you can have like 1 terabyte of memory with AWS right now. So you really need to have like big data. And of course, the coolest solution right now is Spark, and it's a great library. It works quite well. You have this concept of RDD, and also the integration with Python is really good and really cool. Because right now you can use Arrow and you can share the same memory. So, and also you can save file with Parquet, and you can read files from the Parquet format both with R, also Scala, but also Python. So the integration is very smooth. But if we talk just about Python, and we take as an example scikit-learn, it's very hard to put models together. So first, you need to think how you're going to split your data, because it's not easy. You need to split your data across multiple machines, and you need to think how to do this. How you're going to do cross-validation, for example. You also need to think how you're going to aggregate your models, because you're going to have multiple models, and you need to think how to put them together, and it's not that easy, actually, if you start to think about this. If you have linear regression, that's fine, because maybe you can just average the weights, and so you can resolve the issue in this way, but with different models, you have to use different solutions, different techniques. So one of the solutions that you can use is like using assemble methods, so you can just take the majority of between the models or just average them, and it works quite well. But with other implementation, you need to think carefully about this. And of course, there are like different approaches with deep learning, you can compute the SGD and then you can take the average. I think it's a kind of new field. I read some paper like from NIPS 2015. It was very interesting, but still there is a lot of research going on this topic. And just remember that empirically, the result will be different than just training the model on the same data set. So when you start to split, the result will not be the same. So as I said before, Spark is a very good solution. It works quite well. Maybe you don't like Scala or JVM, that's fine. But if you don't want to use Spark, so what do we have for you? So there is Dask, and it is a really good solution. But today I want to talk about something different, about the new cool kid. And the new cool kid is Ray. Have you heard about Ray before? No? Okay. So what is Ray? So it's a high-performance distributed execution engine. So it started as a project inside the HEMP lab at Berkeley University. Actually, it's the same lab for Spark. So the teachers are actually the same. The core is written in C++ with Python support. And it puts together Plasma Object Store, Arrow, Redis, and workers at the end. Plasma is a very cool thing. It's memory. It's using memory like an object storage. So you can just put object there, and after you put an object there, you can just delete this. So you can change this. You can not update this. After you put this there, you can just leave it there or delete this. And if you want to change something, you need to add a new object, a completely new one. And this is how they do, like, to avoid race conditions. They use Redis to keep track of the status of the cluster and all the information about the nodes. They have a global and a local scheduler, and they just have workers to execute the task. So they have an internal implementation of DAGs, so to decide how they want to run code. And I mean, in other words, it's extremely fast. It works well so far. Of course, they are still in beta. It tries to keep the serialization and deserialization cost as low as possible. And you don't have to use Spark or the JVM. So give it a try. Recently, they published a blog post about making your pandas code faster with just one line. And they were comparing pandas with Dask with pandas with Ray. Now, if you check the blog post, it was about using Ray on just one machine. So but using all the cores of that machine. What I would like to see is to use pandas to array to query Parquet files, saved in an object storage with multiple machines. This is super cool because you will be able to just run queries using pandas with multiple machines. And Ray has an internal autoscaler, so you can say, okay, I want to, in case, spin up 5 machines and just run this query, and it will do this for you. And you can avoid using tools like Presto, Impala, or whatever you like to use, or Athena or BigQuery. So you can have your own solution built like with Python, and you can run these queries using the Jupyter notebook at the end. So it's super cool. So let's talk about containers and about Docker. Do you use Docker? Yes? No? Yes, okay. So if you train a model with scikit-learn version 0.18.1, will the same model work with the next version, for example? Yes, no? Well, you don't have guarantee for this. Actually, they say no, you should be careful with this. Because it depends on the version of scikit-learn, on the version of Python, because you're using Pickle. So it's not nice to worry about this stuff. And sooner or later, you will start to face some issue if you don't care about this. I think that with deep learning, it's a little bit easier because you can export the architecture of your network and the size of your weights. So I'm not so sure it can be like version agnostic because they don't specify this in the documentation. I'm curious about asking this during the PyTorch workshop. And the other thing is that, I mean, usually you just save the models and then you just forget about this. And then you have to worry, okay, how can I run this model? What was the version? You can use like Peep, and maybe you can use also Anaconda. The problem is that specifically about Anaconda, it's specific about the version of your computer and about the architecture. So even when you share the requirements for Anaconda, they just work on your computer. If you have like, I don't know, your colleague is using Windows, you will have problems because you have packets specific about, I don't know, OS X, for example. So if you want to ship models in production, probably it's not the best idea. The other thing is specifically, how do you share your models? Do you use like Git, so you put your models inside GitHub and you just pull your models in production, or you do something different? Another issue is when you have multiple stacks inside your company, so you're using like Python, but the main language is something different, like Java, for example. I would say it's quite common still. And it's not bad, but that's fine. So your company or your engineer team doesn't have like an experience with Python or running Python in production. So, I mean, you cannot give them just a GitHub repository with your code in Python because they won't know how to put this in production. And the other thing is, again, how do you put your models then in production? How do you do like, you try different versions of your models? How do you do rollbacks between your models? How can you collect the metrics if you just have a GitHub repository with all your models? And the solution for me, so far, has been to put everything inside a container. Now, it doesn't want to be a solution for all of your problems, but it's definitely a good starting point. Using Docker adds a little bit more of complexity because you need to learn Docker and you need to learn how to use Docker properly. But I would say that it's super easy. I compare Docker to Kubernetes, and for me it's just painful. I think I know Docker very well, but every time that I try to use Kubernetes, I just feel bad. And you can try, I mean, you can train models. You can save models as a Docker image. You will get version for free. You cannot modify the images. And every time that you run a model, you just call the image and you say Docker run or something different if you're using like the cluster. And you put the library with the version inside the image. So you don't have to worry about this. You don't have to worry about the specific version of the library. You just have to worry about having a Docker image, and everything will be inside, and you will be sure that it's runnable in production or whatever, or also on your machine. And so far, at least for me, it works quite well. Of course, you need to evolve your skills, so you need to be like a full stack data scientist, but that's fine. No? So just to recap, with Docker, I think it's damn easy to move things around. It's just super easy. You can use the registry, you can ship your images there, you can have your private registry, so it's literally super easy. You don't have to worry. I mean, GitHub is a part of the flow, but for all the other things, you just use Docker. Again, you get versioning for free because you need to tag each image. And it's stack agnostic because you just ship containers and you don't have to worry about this. No? And as I said before, it's super easy to move Docker images around. You can push and pull images. You have Docker registry as a service, so you don't have to worry about this. Now, when I was thinking about this presentation, I said, okay, let's try to put all these things together. And I started to work on this project called Cassini. And the thing is to have containers, to have an easy object storage, and to have Jupyter plus IPython. And it has to be also platform agnostic. So to have a kind of machine learning as a service is not really that way, but to have an infrastructure where I can just say, okay, I want this Jupyter notebook with this image, with this size of the machine, just create this and just give me an address. And the cool thing is also open source. So I want to show you something. Hopefully the demo will work. Okay, so I have a concept of probe. It's just a Jupyter notebook running. Here you get the address of the probe, so you can access this directly. You get the token to access the token. And you get the blueprint is like the Docker image that I'm using. You get the status is running. And you get the machine size and if you have or not the GPU. So if you take this one, you go there, you get the Jupyter notebook. If you paste the token, you just get inside, and if you want the lab, it's already inside. And I mean, this is really good, but maybe I don't want to use Jupyter Lab. I just want to use Atom. So this is, again, Atom. This is the configuration that you need. Preferences, packages, hydrogen. So this is the base URL, and this is the token. You just need to specify this. Then you get back to the file. And you just get the output, right? And that's not that's not, the Jupyter kernel is not running locally. It's the remote machine. Actually, it's Google Cloud instance running somewhere, I think, in Belgium. So you see all the information about the machine. And you also get the information about the GPU, right? So it's a K80. And last but not least, you can do the same with PyTorch, for example. So you can just have like your PyTorch example, and you can just execute your code in this way, and you will start collecting the output. without using a Jupyter notebook, actually. And the cool thing is that you can just change, the remote kernel. If you want to have a different experience and you don't like to work inside a browser, or maybe you just prefer to use this kind of tool, it works quite well. And if you then decide to have a Jupyter notebook, you can decide to export this as a notebook. But it's like the last step, because before you would just want to work with Python, no? So you can just save the files. You will have a similar syntax like R Markdown, so you need to specify like the cells in this way. So you can just put comments in Python. They will not cause any kind of problems, but they will tell to Hydrogen how to export this to a Jupyter notebook. And okay, in this case I don't have like cargos running, but you can also create object storage. In this case I'm using Minio, and it's like S3. But it's free and you can run this on your machines. Okay, so takeaways for today. So one thing is really important to have a unified data warehouse, so where you put all the data that you have there. Then you can worry about privacy. But before that, it's really important to put your data there. As long as you can, just keep your code running on just on one machine. Use Docker if you can. Try Ray because it's really cool. Try to bring CI and CD practices to your data science workflow. Object storage is really cool. Distributed computing is really hard. And for the last, I didn't have a point. So thank you. This is everything I had. And yeah. Okay. I don't know if we still have time or.
Hello. Okay, we have 5 minutes for the question. Before, I wanted to give you some announcement. So Christian Racca, we will do this talk again this afternoon for the overcrowded population in here.
I didn't say yes, but that's fine.
Yeah, but you're very generous, right? And take care that as you've seen, PyData track this year is quite crowded. So we will have a room just for the streaming upstairs when you see in the other building. Okay, so please, if it's overcrowded, not try to push, but just go to the other room and the speakers will be around. Okay, so we have 5 minutes for the questions. If there is any question, please raise your hand. Okay.
Okay, thanks for your talk. Let's try to put all together. Did you ever try running Docker containers distributed along multiple machines or trying to running Spark tasks in them?
That's complex. Also painful. No, never tried. So I tried to run, actually, this is running on Docker Swarm. So you can run this on multiple machines. You don't have to worry about this. You just specify your cluster, so you just add more machines. And that's all. So with this solution,
using in general Docker Swarm, how do you handle the data that should be distributed across the machine and available to all worker nodes?
You don't worry about this because you use object storage. So you have object storage and you have like an address.
So we're talking about Ray.
No. This is not like an implementation of Ray. Ray is something different. Ray is like a library that you can use. Okay. In case of Ray, Ray is going to pull the data. Okay, it's going to download the data. What is missing right now is that it doesn't work with remote data, so you need to have the data on each machine.
Okay.
Oh, hi.
Hi.
Great talk.
Thank you.
I have a question about CI and CD. You mentioned that we should be using that in our data science workflow. Do you use an automatic process to extract your master branch, and build the Docker image before pushing it, like OpenShift or Jenkins using webhooks?
So I use Travis or GitLab. You mean for the pipeline to create the Docker image?
Yep.
Yeah. I usually use Travis for the public images, and for the private one, I use the GitLab's runner.
Thank you.
Okay.
There are other questions. One last question.
Hi,
Hi.
great talk.
Thank you.
And this Cassini project of yours is like open source or?
Yeah, it's like on GitHub.
Ah, great. Okay.
Yeah.
So, but do you have to have a strong knowledge of Docker to use it? Or?
Well, it's somehow easy if you have some experience.
Okay.
But I wouldn't say it's like for newbies. So if you want to run a cluster, you need to know something how to run a cluster.
Okay.
It's more easier than with Kubernetes because Swarm, I don't know, it's super cool. I don't know why people are using Kubernetes because Docker Swarm just work really well. And you just need to create like multiple machines, then you have to start Docker Swarm, and you just add nodes easily. So yeah, it's really easy actually. I mean, I need to work a little bit on the documentation, but it's not rocket science.
Okay, great. Thank you.
You're welcome.
Thank you again, Christian.
You're welcome.
Great applause for Christian.